What if I told you that somewhere 390 light years away, there's a cosmic enigma that could rewrite everything we thought we knew about the universe? Imagine a celestial structure so ancient that it predates the very stars that light up our night sky. As the James Webb Space Telescope unveils this shocking revelation, we're left questioning. Is the Big Bang Theory itself in jeopardy? Strap in and prepare for a mind-bending journey through time and space as we explore the secrets of the cosmos that challenge our understanding of existence. The James Webb Space Telescope, our newest eye on the universe, has recently captured a glimpse of something utterly astonishing. A celestial structure that appears to have existed even before the birth of stars. Yes, you heard that right. This extraordinary finding raises a fundamental question. How could a structure exist that predates our universe? Is it possible that the Big Bang Theory, the cornerstone of modern cosmology, might need a significant overhaul? Buckle up as we dive into this cosmic mystery, guided by the revelations of the James Webb Telescope. Now, let's shift our focus to a fascinating star named HD 140283, affectionately nicknamed Methuselah. This ancient celestial traveler resides in the constellation Libra and is not just another twinkling point in the sky. It boasts a rich history that dates back over 12 billion years. To put that into perspective, our own Milky Way galaxy was still in its infancy when Methuselah began its long journey. Picture a time when our galaxy was absorbing smaller dwarf galaxies, and Methuselah was already out there, witnessing the cosmic dance. But here's where the story takes a captivating turn. Initial estimates suggested that Methuselah could be a jaw-dropping 16 billion years old. Yes, that's older than the universe itself, which is thought to be about 13.8 billion years old. How can this be possible? Are our cosmic clocks broken? Or is there something we're missing? To unravel this celestial enigma, astronomers take on the role of cosmic detectives. Think of stars as ancient light bulbs, shining brightly for billions of years, but gradually losing their glow over time. To crack the code of a star's age, scientists must observe various factors: how fast the star spins, its brightness, and even the gossip it produces in the form of magnetic flares and bursts of energy on its surface. It's almost like eavesdropping on a star's innermost conversations. Using advanced techniques, astronomers have discovered that Methuselah, with its low abundance of heavy elements, belongs to a different category of stars known as population 2 stars. This classification is significant because it provides clues about the star's formation and age. While our Sun is a relatively young population 1 star, rich in heavy elements, Methuselah embodies a much older legacy. Recent calculations suggest that Methuselah's age may actually range between 13.6 and 15.3 billion years, raising even more questions. If it truly is as old as the universe, how does that align with our understanding of cosmic evolution? This leads us to the concept of stellar populations. Stars are categorized based on their chemical compositions, with population 3 stars theorized to be the first stars to form after the Big Bang. These hypothetical stars, if they exist, would be like cosmic unicorns, massive and hot, blazing through their fuel and creating heavier elements through fusion. So, does Methuselah's extraordinary age challenge the very foundation of the Big Bang Theory? It's a puzzle. Statistically speaking, there's a 70% chance that Methuselah fits neatly within the universe's timeline, but a 30% chance it could be older than we believed. Imagine rolling a 6-sided die and hoping for that elusive 6. That's the gamble astronomers are taking here. Now, hold on to your seats, because the plot thickens. What if the universe is actually older than we currently think? Recent research from the University of Ottawa suggests a staggering possibility. The universe could be a jaw-dropping 267 billion years old. This theory, presented by Professor Rendra Gupta, revisits ideas from the 1920s, proposing that as light particles called photons travel through the cosmos, they lose energy, affecting our measurements of cosmic distances and ages. This isn't just a minor adjustment in our calculations. It represents a monumental leap in our understanding of the cosmos. Picture this. If the universe's age is indeed 267 billion years, then we are mere fleeting moments in the grand timeline of existence, like a blink in the vastness of time. Shifting our focus back to our very own Milky Way, recent measurements have unveiled a captivating cosmic ballet among stars on the outskirts of our galaxy. It seems these stars are moving in slow motion compared to their counterparts in other galaxies. What's going on here? Enter the European Space Agency's Gaia satellite, our cosmic detective in this mystery. By meticulously mapping nearly 2 billion stars, Gaia has provided crucial insights into their movements and behaviors. The satellite's precise measurements have led astronomers to rethink their assumptions about galactic dynamics. Surprisingly, the stars at the outer edges of our Milky Way seem to be taking it slow, challenging the conventional wisdom about their speeds. So, how do these star speeds reveal the weight of our galaxy? It's akin to gauging the size of a crowd by observing how fast people are moving. Armed with Gaia's data, astronomers have estimated the combined weight of our galaxy's gas, dust, stars, and that elusive dark matter to be around 200 billion times the mass of our Sun. While this sounds impressive, it's actually about 5 times less than what we previously thought. This revelation opens up a whole new set of questions regarding dark matter, the mysterious substance that exerts gravitational influence yet remains undetectable by traditional means. One possibility is that we may have been overestimating the amount of dark matter in our galaxy, like discovering there are fewer ingredients in your favorite cosmic soup than you originally thought. The implications of this cosmic reevaluation are monumental. It challenges the very foundations of our understanding of not just our Milky Way, but potentially every star-studded corner of the universe. As Stacy McCarr, an astronomer at Case Western Reserve University, aptly puts it, this could be a cosmic game-changer. Let's take a moment to appreciate the legacy of astronomers throughout history. Think back to the 1970s when Vera Rubin and her team set out on a stellar adventure to study how stars move in other galaxies. Conventional wisdom suggested that stars at the outskirts of galaxies should be slower than those closer to the center, much like how Mercury zips around the Sun while Neptune takes its sweet time. But here's where the cosmic surprise emerges. Rubin and her team discovered that stars at the far reaches of galaxies were moving at nearly the same speed as their neighbors closer to the galactic core. It was like uncovering a cosmic disco where everyone, regardless of their location, was dancing to the same beat. This finding hinted at the existence of something hidden and mysterious. Dark matter, the invisible heavyweight champion forming massive halos around galaxies. As we journey through this vast cosmos, we realize that our understanding of the universe is still in its infancy. Like early astronomers such as Copernicus and Kepler, we stand as newcomers, wide-eyed and eager to explore the cosmic wonders that surround us. Our Earth is but a tiny island in the grand sea of space, swirling around the Sun among countless stars and galaxies. This quest for meaning among the stars lies at the heart of scientific exploration. Even when faced with surprises that challenge our beliefs, our curiosity drives us forward. Each answer reveals new questions, fueling the fire of exploration and understanding. The cosmos is a treasure trove of ancient wonders, each one waiting to be discovered and cherished. So, as we gaze into the night sky, let's embrace the adventure that lies ahead. Who knows what astonishing discoveries await us in the future? The cosmos is calling, and our journey is only just beginning. Thank you for joining us on this cosmic exploration. Stay curious, and remember to keep looking up.